Today we're going to talk about square roots in modular arithmetic. Square roots. Square roots are a funny old thing. First of all, you learn that you can only take the square root of positive numbers and 0. And then at some point someone says to you, oh ho, well actually we're going to say that you can take square roots of negative numbers as well, and they're these things called imaginary numbers. And you throw up your arms and go, oh, that's ridiculous maybe, and then you get used to it. So now we're going to try taking square roots in modular arithmetic. How is that going to work? Let's try doing it in, let's do it mod 8. So here's a question, what are the square roots of 1 if you're doing modular arithmetic? So that means that you have to find any numbers a, i.e. we're trying to solve a squared is congruent to 1 mod 8. See if you can have a think about that. All you have to do is try every number up to 8 and see what happens. So have a go at that. Have you had a go? So let's see. 0 squared is 0. 1 squared is 1. 2 squared is 4. No surprises there. 3 squared is 9, but 9 is congruent to 1 mod 8. 4 squared, I'll go up here now. 4 squared is 16. Well, that's 0. 5 squared is 25, and that's congruent to 1 mod 8. 6 squared is 36, that's congruent to 4. And 7 squared is 49, and that's congruent to 1. So, this is a bit strange now, isn't it? Look, 1 has several square roots. It's got 1 and it's got 7, which is minus 1, so those are the ones we would expect. But it's also got 3 and 5. So the square roots of 1 are 1, 3, 5, and 7. Well, that's a bit strange. We've got 4 square roots of 1. Who else has a square root? The square roots of 4 are what you'd expect them to be, right? They're 2 and 6, which is minus 2. And then we've also got 2 different square roots of 0. So we're used to 0 having a kind of repeated square root, but this time we've got 0 and 4. So that's a bit strange. So other numbers with square roots, so 4 and 0 also have square roots, but only 2. So each of them is a kind of repeated square root because 4 is really 4 and minus 4, right? And 0 is really 0 and minus 0. So this is a little bit strange. Let's try somewhere else, shall we? Let's try mod 7 instead. Let's square everything mod 7, so we only have to go up to 6 now. So we get 0, 1, 4. 9 is the same as 2. 16 is the same as 2. 25 is the same as 4. And 36 is the same as 1. So now it's a bit more sensible, right? 1 only has square roots plus and minus 1. 4 only has square roots plus and minus 2, and 2 has square roots plus and minus 3. So here, everything has 2 square roots. So why don't you try for different values of n, having a look and seeing how many square roots everything has, and see if you can work out what's going on. Have you worked out what's going on? The answer is, it depends. Well, it depends whether n is prime or not. So if n is prime, then it's more sensible. If n isn't prime, weird things happen. This is all part of something much more profound to do with group theory and ring theory, which I won't talk about now, but it's an interesting question to see which one you think is more interesting. So if it's prime, things kind of happen a bit more sensibly, but is that interesting or not interesting? Is it more or less interesting to be sensible? Or is it more interesting to be weird?